Okay, let's dive right into this. Welcome back to our explainer on a foundational concept in economics that literally governs every single purchase we make. We're talking about the price elasticity spectrum. Today, we're going to unpack exactly how we all react to prices, shifting from pure textbook theory straight into the messy, everyday economy. So, I want you to start by asking yourself this. Why does a 10% price change sometimes create an absolute tidal wave of consumer reaction, and yet other times it barely causes a ripple? I mean, why do we completely abandon some products when they get just slightly more expensive, but then blindly continue to buy others no matter what they cost? Well, the answer lies entirely in the degree of responsiveness. And this comparison brilliantly illustrates the real-world stakes of what we're looking at today. Take airline tickets. A 10% drop in price there, that can cause a massive 40% surge in ticket sales. People suddenly book vacations they weren't even planning. But then compare that to table salt. If you see a 10% price drop there, the quantity demanded barely shifts, maybe 0.5%. You simply don't start salting your food exponentially more just because the salt was on sale. To really understand this, we need to pin down our core mechanism. Price elasticity of demand is essentially a measurement tool. Mathematically, it refers to the ratio of the percentage change in the quantity demanded of a commodity to a given percentage change in its price. But really, just think of it as a sensitivity meter. Are consumers hypersensitive, or are they completely numb to the price tag? For this masterclass, we're taking a structured tour across the entire spectrum. We will unpack 5 distinct degrees of responsiveness: perfectly inelastic, perfectly elastic, unitary elastic, relatively elastic, and finally, relatively inelastic. Chapter 1. Perfectly inelastic. Zero change. This is a scenario where the price changes, but the consumer's reaction is absolute zero. In math terms, we represent this as EP equals 0, with the EP standing for elasticity of price, of course. An outcome of 0 means that the quantity demanded does not respond at all to a change in its price. Whether the price spikes way up or plummets down, the exact same quantity is demanded. Now, the geometry here is absolutely fascinating. The demand curve is a perfectly vertical straight line running parallel to the y-axis. If the price sits at OP, the quantity purchased is OQ. But if that price jumps all the way up to OP1, the quantity purchased stays absolutely frozen at OQ. It literally does not budge. The visual represents pure, unyielding rigidity. So what forces this kind of rigidity? Absolute necessity. Classic textbook examples include basic salt or, more crucially, life-saving medicines. If you rely on a medication to survive, a price increase just isn't going to stop you from buying the exact dose you need. Though we should definitely note that in the real world, cases of perfectly, completely inelastic demand are actually very rare. Moving right along to Chapter 2, perfectly elastic, infinite change. Let's swing the pendulum over to the complete opposite end of our theoretical spectrum. In this rather bizarre scenario, EP equals infinity. What this implies is that consumers are prepared to purchase an infinite amount of a good at one specific price. But, and here is the kicker, if that price increases by even the tiniest fraction, demand drops to absolutely 0. Consumers will completely abandon the product. Visually, this is totally different. The demand curve here is a completely horizontal straight line, parallel to the x-axis. At the price level of P, demand stretches out to infinity, but moves slightly above P, and there is literally no demand curve to be found. Just like perfectly inelastic demand, this is an extremely rare, purely theoretical extreme in the market, but it's essential because it sets the boundaries of our spectrum. Chapter 3. Unitary elastic perfect balance. We have officially arrived at the exact mathematical middle point of our spectrum, and I absolutely love the elegance of this concept. A unitary elastic demand curve assumes the shape of a rectangular hyperbola. It extends towards the axes in a beautifully uniform way, but theoretically, it never actually touches them. It represents a state of perfect proportional harmony between price and quantity. So the crucial point here is this perfect 1-to-1 ratio. When EP equals 1, a given percentage change in the price of a commodity causes an exact mathematically equivalent percentage change in the quantity demanded. If a store drops the price of a good by exactly 10%, the demand for it rises by exactly 10%. It is perfectly balanced. Chapter 4. Relatively elastic, luxury goods. Okay, let's step out of those rare, theoretical, extreme scenarios and get into the real, messy, everyday economy. Here, the demand curve is noticeably quite shallow or flatter, stretching outwards horizontally. This flatter curve tells us a very specific story. Consumers here are highly sensitive to price changes, so EP-CLD is greater than 1. This means that the percentage change in quantity demanded actually exceeds the percentage change in its price. Let's look at the math to prove it. Imagine a 10% fall in the price of a commodity. In a relatively elastic market, that small 10% drop might cause a massive 20% jump in the amount demanded. What triggers this hypersensitivity? Luxuries, for sure. Think about diamonds, high-end jewelry, or upgrading your home with brand new air conditioners. These aren't survival goods, so if the price drops, consumers flood in. But if the price goes up, consumers easily walk away or just delay the purchase. Chapter 5. Relatively inelastic. Everyday necessities. This is arguably the most common degree of elasticity, the one that silently governs your daily survival budget. And the visual contrast is striking. The demand line here is noticeably steeper, dropping down sharply rather than stretching out flat. This steepness illustrates a reality where a price change causes very little change in actual demand. Here, EP is less than 1. Let's run those numbers one more time. If the price falls by 10%, it might lead to only an 8% increase in demand. The percentage change in quantity demanded is strictly less than the percentage change in price. Why? Because these are everyday necessities. We're talking about food grains, basic clothing, everyday groceries. Even if a basic staple like bread drops in price significantly, you aren't going to start buying triple the amount of bread. And conversely, if the price goes up, well, you still have to eat, so your demand doesn't drop off a cliff either. Seeing these concepts side by side really helps permanently cement this in your mind. A flatter curve represents luxury and extreme price sensitivity, where a tiny price tweak creates huge behavioral changes. A steeper curve represents necessity. We are stubbornly tied to these everyday goods, so price changes result in only minor adjustments to our shopping carts. Which leaves us with this final thought. Think back to the items you purchased today. Maybe it was a cup of coffee, a tank of gas, or maybe you finally bought that new tech gadget you've been eyeing. Based on the 5 degrees of the spectrum we just explored, were your choices driven by a tidal wave of elasticity or just a tiny inelastic ripple? You know, understanding the spectrum doesn't just help you pass an economics exam, it decodes the unseen forces shaping your wallet every single day. Thanks for joining me on this explainer. I hope this masterclass made the elasticity spectrum perfectly clear. See you next time.